Biodiesel. And I don't know if some of you noticed that if you've been to the collective biodiesel conference before in past years, you may notice the little name change, that this year it's the collective biofuels conference. And so one of the reasons why we did that was because we wanted to start expanding the focus and start looking at all these different byproducts and things like that that can go into the process of making biodiesel and making it more sustainable. And so one of the things we're going to look at is we're going to talk about biogas in this and about some other projects. But first of all, I guess I should introduce myself. My name is Brian Roberts. I work with a nonprofit called Cowichan Energy Alternatives, which is kind of almost the how do you say, it's a nonprofit fundraising side. It does a lot of the kind of heavy lifting as far as the co-op is concerned, does the oil collection and the production, a lot of the research. And the co-op, which is largely the umbrella organization that CEA is a part of, the Cowichan Biodiesel Co-op is largely a distribution co-op, and where these different organizations come together. So I'll talk about some of the things that we've been doing in our joint partnership project, the Cowichan Biofuels Initiative, which has led to the production of the Cowichan Biofuels facility. And Kealan Gell will be talking about some of the work that he's done with us, but also some other projects that he's done, and how we're going to kind of combine some of those ideas. We're doing a bit of a biogas project. So that's Kealan Gell of Offgrid Earth and Water. I always think it's kind of funny because he's doing biogas, and it should be Offgrid Earth, Water, and Gas.
And gas.
You should consider that.
Yeah,
the utility.
It's a great marketing tool to talk about the gas that you produce and to get people really excited about the fact that you're producing gas. It's kind of a bad joke of bad smelling gas. Anyway, so I stayed away from the energy side of it actually in the name for a good reason, and that was to focus on all of these byproducts and using them as fertilizer, because ultimately these nutrients that you're discarding when you use part of the plant and not all of the plant need to end up in the soil if you want a closed loop for them.
But we're getting ahead of ourselves, so we'll take a little bit of a step back and we'll kind of outline what we're going to be talking about. So the title, Biodiesel Byproducts and Integrated Processes, we're going to be talking about feedstock byproducts. We're going to be talking about waste vegetable oil collection, pre-processing, and biodiesel byproducts. And we're going to be talking about mostly, our focus is innovations that lead to increased sustainability all along the process. So this is I think people recognize this as being a pretty generic kind of diagram explaining or just kind of showing the closed loop that is biofuels production on more of an industrial scale kind of thing. But if you kind of look closely, and maybe from a small scale and from a real sustainability perspective, there's a couple of things that are kind of problems with this as well. So one is that this takes fertilizers and fossil fuel inputs at the renewable resource end, growing the plants, and that comes from an outside source. Dollars, many dollars in large-scale biodiesel production. So as a small, sustainable community biodiesel project, how do you make it more sustainable with less dollars? So resetting this again, what we're looking at is the feedstock and the byproducts as a way of increasing, I guess, the productivity and the sustainability of the biodiesel production. And then this green arrow right here, where to truly make it sustainable, you've got to think about the feedstock resource, feeding that back with any carbon or other nutrients that you don't want to waste. You want to put it back into the soil. And so this is really kind of largely addressing that food versus fuel issue to try and keep on giving back to the soil. And so we're seeing, so the food products, waste vegetable oil collection, pre-processing, and how do we bring that back to the renewable resource again? And then next, with looking at the byproducts of the biodiesel itself, and how to bring that back to the renewable resource. Next slide. So again, this is our outline, and this is why I'm also calling it, since we're talking about everything kind of but biodiesel, you hit that again, everything you wanted to know about innovative, sustainable biodiesel production that doesn't directly involve biodiesel. So next slide.
All right.
Yeah.
So I'm going to talk a little bit about feedstock byproducts. Now I understand that most people in the room have made biodiesel probably and are pretty familiar with the process of going from vegetable oil to fuel. But there's along the way, to create that vegetable oil in the first place, there's various byproducts that are produced at that level. For example, there's in biodiesel, there's what's called, well, usually a seed meal, depending on what kind of oil crop it is, but here in Canada, the biggest one is rapeseed. We call it canola up here. So I'm calling that rapeseed meal. And I've done some experiments in the Netherlands actually on rapeseed meal and whether it can be used in soil. As the massive increase in production of biofuels, you're going to have a massive increase in production of all these byproducts. So, general question. Looking at feedstock byproducts and whether they can be used in the soil, I'm going to talk about that. I think that's it for this slide, isn't it? Is canola, okay, so here, now this is getting a little bit more specific. I explained what canola meal is. I'm going to call it rapeseed meal, but it's canola meal. Is it phytotoxic? Phytotoxic means toxic to plants. So that's pretty important if you start spreading it on agricultural land. Is it toxic to plants? It's one of the standard tests people do. And again, when you separate the oil from the rapeseed meal, or there's many other parallels in different kinds of fuels, all of the nutrients are left with the seed meal. There's very little nitrogen, very little phosphorus, potassium, calcium. None of that stuff is in the fuel. It all is in these byproducts. And so these nutrients, this is a pretty important issue that I was already sort of getting excited about before I even started. Can it be used as fertilizer? Now the test for phytotoxicity of rapeseed meal, I'm just going to go through this experiment real quick because we got some interesting results. So it's a phytotoxicity test. It's a standard OECD test used all over the world. Most governments use it. We tested a whole bunch of different bioenergy byproducts. So there was stuff from biochar, there was bioethanol, biodiesel, and biogas. And we applied it on a rate based on fertilizer per hectare. We did lots of replicates, and the way we actually did it was we put seeds of four different types of crop plant, into these little jars, put seeds in the soil, and let them germinate, and watched and measured to see how long the seeds, the roots and the shoots are. So you can see here the shoot to root ratio is very different, and that's the measure of phytotoxicity. If something is toxic to a plant, this is a really good way of telling that the root, see how this root is totally stunted and short, versus this one is like a control or a non-toxic version. You can kind of imagine how that works. You leave the seeds in. It's in a total controlled environment where the humidity, temperature, all that's controlled. You leave it in for 3 or 4 days with the exact humidity, and then you measure the roots. And you do it all by hand, so it takes hours and hours.
Just real quick, what do you mean by biochars? What did you mean by that? You just burned up the step.
I didn't produce it myself.
Is that the process though? You took the meal and...
Okay, there was a whole range of different products that we used, and so some of them weren't even from rapeseed meal.
And so one of the next slides will actually show that.
Yeah, we have so this is the result. I'm trying to skip through this experiment because the only thing that's really relevant here, I think, is the rapeseed meal, but we can talk about it more. Here's the results in terms of phytotoxicity. So this graph, percentage of the control is the y-axis. 100% of the control, that's what the control was. So that means there's no phytotoxicity. It's just straight soil. There's nothing with it. That's the natural root length. Whereas everything else is compared to the control, to make things simple. So the first 5 are not significantly different from the control, whereas the last 2, you can see these are less than 20% of the control. This is the roots of lettuce, the length of the roots of lettuce. So this indicates that there is significant phytotoxicity in these 2 products, which just happens to be biodiesel rapeseed meal. And that was quite an interesting result. You want to flip to the next slide? This is the exact same thing, the same y-axis, but this is with time involved. So this is immediate, this is 10 days, 20 days, 30 days. And well, you can see this is phytotoxic, and then after 30 days, That's the control. So it decays in the soil. So for us, this was quite interesting, and it's supported by various literature as well. But it means that if you put rapeseed meal in the soil, it will be phytotoxic to the plants for the first 14 days and then, or 30 days, and then it'll not be phytotoxic anymore. And that is roughly the half-life of a conventional herbicide. So this stuff could be used as a herbicide.
Non-selective.
Which is really interesting, because for something that we actually, we're looking at maybe as being a soil amendment or something you could put in as a fertilizer, you're actually finding now that it has this phytotoxic quality. But that can also be good too when you're laying a field fallow or something for a while and you want to suppress weed growth. But after 30 days, you're finding that it does have beneficial qualities again, because the carbon is going back into the soil and other nutrients. So it's got a limited time period when it's phytotoxic, which makes it quite useful.
Go ahead.
Yeah, I mean, this would be the ideal product, right? Something that gets rid of weed,
Yeah.
then turns into a nutrient.
Yeah. It's a natural herbicide. You know what? There's actually a fair number of natural herbicides out there that are somewhat suppressed by the conventional, crop protection people. So yeah, I think we should promote this. If anybody is making their own oil, if anybody has access to this stuff, which sometimes it's fed to livestock, there are some other uses for it.
Was this being already dried out? Or was it,
The what?
like, would you store it dried and then you use it at a time?
Yeah. It's a dried product. You can usually anywhere they're producing canola oil, rapeseed oil, it's not worth much. It's pretty cheap stuff.
I think the question is about storage life.
Yeah, that's what I was wondering. Like, it seems like it degrades over time, and is that because it's
Oh,
composting or?
Well,
what is it?
that's right, and this is in moist soil. Whereas if you're storing it, like, if you want to be able to store it for a while, keep it dry. I mean, it's like a grain product. It'll last for as long as it's dry. Yeah, the stuff we used was actually, it'd been around for a while.
What's the value of that, of canola meal fed to cattle?
15 cents a pound.
So is that more valuable as a meal or?
Okay.
Can I jump in and elaborate a little bit? Canola is a brassica.
Yeah.
It is one of the few plants that does not have what they call a mycorrhizal association, that is a food crop. It has an association with its own bacteria. And the seeds that you're sprouting, they would be affected by that. That's also the same affinity that inhibits cancer growth in our lower intestine. They're sulfur compounds. And over time they get complexed with microbiology and become...
Which chemical substances are you talking
From the
about?
canola.
Right.
The canola right away.
Glucosinates? Is that?
They're sulfur compounds, sulfamines or something. But anyhow, they have found, I did a lot of plant nutrition in the Salinas Valley of California, and they have found that if you follow a broccoli crop, which is pretty closely related, it's Brassica oleracea, if you follow it with bell peppers, it's a much happier, healthier crop, because the residues of the broccoli give a lot of the plant pathogens a bad time.
Perfect.
And it allows the peppers to get established.
Well, I think that actually, that's a good narrative, and the substances that we're looking at here, what we found that they inhibited phytotoxic substances, which has been well researched, were certain substances, but all kinds of plants have all kinds of allelopathic chemistry going on, and if we can use that, which this is what we're both talking about, that's a huge benefit. It's better than spreading Roundup everywhere. I wonder if we should move on.
I had a question.
One last thing.
Have you all looked at, is this the yellow grease? Did you look at the byproduct or the food substance and what you can use for that? That's probably what a lot of people in this group.
I think we'll get to that real soon. Where are we at here? Okay,
So it's also interesting. I don't know if you've ever noticed, and just before I get to this, the actual canola oil itself, or if you've ever spilled it on the ground or spilled it on in your backyard, that it actually will kill off the grass, but then it'll eventually break down. And so it's another thing that it seems like that's something that can be used for like weed suppression or whatever else. But that's a whole other question to be looked at later on, and we won't really kind of address it here. But what I do want to go on to is, and we're going to be bouncing around a little bit here, because as I say, we're going all around the edges of biodiesel production and looking at innovation and trying to make things more sustainable. So the question I have here is, how can a small grassroots biofuels organization expand oil collection to meet growing local demand for sustainable biofuels without large capital investments in new collection equipment? Right? So this was the problem that our organization had as we were starting to expand from going to restaurants and collecting the jugs and putting them in the back of your Volkswagen Golf to actually feeding a growing demand from a co-op. So one of the things we did was we started bringing the oil to us, and we started getting innovative with where it's coming from as well, our source. So there's a whole untapped supply, and it just so happens that something like this is a great way, a great foot in the door with your local municipality, because they spend millions of dollars a year keeping this stuff out of the wastewater system because it clogs up drains and everything else. So even though the amount that we get is marginal, the goodwill we get from doing this and providing this service is amazing. So next slide. But really, we all know that it's the commercial restaurant and catering organizations or whatever else, fish and chips pubs that you get the bulk of your waste cooking oil from. And so we had very little equipment, and looking at recycling and how to up our collection, we came up with this. We have an old Ford F-150. And we had a propane tank which we could use as a vacuum tank, and we tried using this old dairy vacuum pump system, and it didn't work. It was actually for milking cows. And it kind of worked, but we couldn't get the oil out when it was after it was in the tank without being able to let it drain by gravity. And so we actually there's probably some ways we could have addressed that, but the pump really was insufficient. So what we actually did was we found we needed something that you could use with a 12-volt system, which is very hard to find, with a vacuum pump that gives you enough power to actually collect the waste cooking oil. And so as a company called LMT out of Illinois, which had this great 12-volt pump that they were starting to put together, and they were going to use it for porta potties. It's basically for cleaning out septic systems and that kind of thing, or sewage. And so we started talking to them. We found that they had this online and thought, wow, that can work. And so they actually built us a prototype, and we got the very first pump, and so we tested that. And we actually found that it was quite successful. We also found some problems with it too. First of all, it was only designed to suck. It didn't, and everyone knows in oil collection, it's best if your system both sucks and blows. So it didn't blow. And so we needed to design that. Exactly. And so actually, that was one of the projects Kealan worked on with us, about actually rerouting the hardware so that we could redirect so that it could actually blow out the tank as well after it had been collected. The other thing, there were a couple other little technical difficulties, but I won't really go into it. But working with this company out of Illinois, next slide, they ended up coming up with a brand new product, the EVAC 1250 or 1205 now instead of the 1204, and it does all those things that we needed from it. And so that's actually available to small scale collectors now who want to put something in the back of a pickup truck or even bigger. So, what's that? About I think about $2,200 or something, around maybe. We got ours for a lot cheaper because it was the pilot project. But anyway, so I think it's probably around $2,200 US. So next slide. So next kind of question, with innovative pre-processing. What is an innovative, sustainable approach to supplying the large heat requirements for pre-processing waste vegetable oil and for also the processing of biodiesel? But really, for the most part, I'm focusing on the pre-processing of the oil itself. So next slide. So innovative pre-processing. What we did was we looked at a very innovative use of a solar thermal system. In BC last year, through Solar BC, there were these great grants for setting up solar hot water systems. Perfect. So why can't we apply that to waste cooking oil? And that's exactly what we did. So we set up a solar thermal waste cooking oil system using 3 Biodiesel 200F solar panels. Next slide. And we got a couple surplus Weissman heat exchangers. And so it's always great to have a mill or a big industry around somewhere that's constantly, getting rid of their equipment and revamping stuff. So what we found is that this has been so successful that 450 liters of oil can get heated up to 60 degrees Celsius probably by around noon on a reasonably overcast day. As soon as it's sunny, well, actually, I think it's around 1 o'clock, all the heat starts discharging because we're not using enough of it. So we're actually going to be adding another heat exchanger for a total of about 900 liters that it can heat. And you're kind of getting an idea of the scale of our system here. We're still kind of a community scale system, but we're all geared to do about 1,000 liters a day of fuel in the processing. So next slide. So now on to biodiesel byproducts.
All right. So can anybody guess what this guy is doing?
Moving gas towards some sort of outlet.
He's just a crazy dude, but what he's standing on is a big methane producing vessel called the Alligator, I think. It's manufactured in Holland or somewhere in Europe. You just fill it up with cow manure and it gets huge. The methane, expands and whatever. And I think he's trying to do a kung fu move or do some kind of like dance or something. But anyway, that's just for fun for him.
So could you rent those out for kids to jump on too then?
Definitely. In fact, the only danger is that it gets punctured and it blows up. So that's
Don't smoke while
yeah. So the brown grease. This is an issue for a lot of people, right? On your end of things, you have brown grease. Has anybody got a good idea of what to do with it? All right. Yeah. Throw it at somebody? Okay. So our idea is making biogas out of it. It's got a lot of energy, and the glycerin too, although of course you can do other things with glycerin. I'm gonna talk a little bit about biogas potential. Now, first of all, there's a guy in the room who's doing his master's thesis on biogas. I have to be careful what I say here. But so to start with the reactions that he's looking at, this is a trench, and there's a long, basically like plastic bag trench that you just put in your manure, and it heats up in the sun, and you get gas coming out of it. So this is mostly South America. In India and China, they have these kind of domes built into the ground out of bricks, and then they put their manure in there, and it produces methane. And there's some plastic ones, and there's all kinds all over the world. Most of the ones in the industrialized world are very large scale. Most of the ones in the developing world are small scale. Anybody want me to talk more about biogas? Any quick questions? It's a matter of you produce methane and a few other gases out of waste organic material.
What do you have to do to purify it?
To purify the gas? Yeah, you have to scrub the gas. You have to remove the hydrogen sulfide, and a lot of people like to remove the water vapor and CO2 as well. I could get into the techniques for that, but maybe we'll do it later. Okay, so I'm just going to show you a few more photos. This is a Chinese commercially available system for black water, but you can put anything through it. You can buy all this stuff, biogas lamps, biogas generators, Nepal, India. It's fairly well established stuff. And even in the industrialized world, there's some people out there who are building these things, and this is a system that I was involved with putting together in the UK for using food waste and heating a greenhouse. This is our gas storage and pasteurizer. This is just an idea of this end of biogas, which is quite uncommon in the industrialized world, the small scale stuff. This is a system I built at my house in Holland with using compost and human manure and stuff like that. And here's our gas storage, and we ran it into our kitchen stove so we would cook on it. It's probably simpler than brewing alcohol or making biodiesel. It's really a simple process to do. So just to get your head around this biogas situation, I told you about this bag already. This is another sort of wacky fiberglass biogas reactor in the UK, built by a friend of mine, who's a complete genius.
I have a question, life cycle questions, life cycle and disposal of the byproducts after basically the feedstock is spent from the production perspective of gas.
Right.
How long is it? I mean,
Okay, so the process, try and address the life cycle thing. Okay, the process varies from a hydraulic retention time of like 20 days to 50 days, something like that. So so you need a big tank, it needs to sit there for a while. The effluent comes out. It's a little bit like liquid manure. It's very liquid. A lot of the carbon, a lot of the solids have turned into gas, so you get something that's much more liquid than what you put in. And that liquid is generally stable and a very nice fertilizer. More on the life cycle thing? Or? Okay. All right. So here's the punchline. I'm going to start with glycerin. So the estimation of the biogas yields from these things. Glycerin, very well established, totally awesome. If you have glycerin and you don't know what to do with it, find a biogas system for it. In Germany and in Wisconsin and in various places where there's a big biogas industry and they have these big tanks running, especially in Europe, glycerin is sought after by the operators of biogas, because you put in a little bit of glycerin. I apologize because I should have put in more things to compare it to, but I can tell you off the top of my head some of the values for other stuff. But glycerin is extremely rich in energy. Like you just get, it's like an explosion. You put it in there. Go ahead.
Would you compare, so like we work with the wastewater treatment plant in California.
Yeah.
And they shared with us data that said that they were getting 1.5 times the BTU content of the glycerin increase in methane production.
What was the other feedstock they got the energy from?
So they were using glycerin in addition to, of course, it's a wastewater treatment plant.
Sewage.
So it's sewage. So they were getting, so they put in, they're putting about 1,000 gallons a week in. And 1,000 gallons of BTU, 1,000 gallons of that kind of glycerin was about, I think, 70,000 BTU per gallon. And they were getting an increase in weekly production on the order of 100,000 BTUs.
Well, there's at the micro scale where this stuff all happens, like the little bacteria, any number of things could be happening. It could change the surface tension of the
For
solids.
some reason, it's increasing the digestion.
Somehow it's
of
increasing.
everything else too.
Well, that's something I haven't ever heard about, but I'm sure it's possible.
That's from East Bay Mud in Oakland. It's a wastewater treatment
Cool.
plant.
Anyway, the point is glycerin is well established and very good for biogas. Go ahead.
Question, with the glycerin, if you go to a wastewater treatment facility or you do it, is there anything you have to do prior to putting it in there? Have you found when you played with it, can you leave the methanol in it? Can you leave the lye in it?
The bugs love methanol.
Yeah.
That's what I thought, so.
That anything that's edible to a bacteria, which is most things. Yeah, I mean, you do need to control the pH to some extent.
Okay.
It shouldn't go too much above like 8.5 or so.
How do you control temperature?
It needs to be warm. You need to heat it.
How do you keep it from getting too warm?
It doesn't actually. The reaction doesn't really produce its own heat.
Okay.
Maybe like it's like composting with air. That oxygen is basically like it's almost like burning. It's like creating heat that way.
But anaerobic.
With anaerobic digestion,
Okay.
very little heat. Yeah.
Also, I think it's a problem because you can't have too many glycerin in a digestion system.
Yeah.
But there's a company in Washington that at least is telling us
Yeah.
that is telling us that it has to be, not the primary ingredient. It has to be secondary.
But you could add wood chips or some other kind of waste.
Oh, I see. You're saying it shouldn't be the only ingredient.
Right, you should be in it.
That's right.
It should be a manure digester where you're sweetening
You add a little bit of glycerin.
sweetening it with glycerin.
That's right. The main reason for that is any very high energy feedstock in a biogas system, there's two stages. There's basically organic matter to acids and then acids to methane. And if you overload, if the first stage goes too fast, organic matter to acids, you get too much acid buildup and the pH drops. And so you can run a digester on anything that digests, but when you have a very high energy feedstock, that first step has a tendency of going very quickly, and so it's very hard to control without, quite a.
What about the starting microbes? You have to like keep a batch.
Cow manure. Cow manure.
Starts with cow manure.
Cow manure is just so great. You can use a seed. What's better actually is a seed from a existing digester, but I'd say at some point every digester probably started with cow manure at some
And then
point.
you just keep some for the next batch, clear it out, and bring
Most of the systems I showed there are continuous flow.
like plug flow.
So it has to be a little bit plug flow so you don't get mixing from the far ends, but yeah, there's completely mixed a lot of completely mixed biogas reactors in the world as well that work pretty well.
And of course, if you manure is a great addition to the glycerin for a number of different reasons. If you use potassium hydroxide as your catalyst, then of course the three limiting plant nutrients are potassium, nitrogen, and phosphorus. And so if you're mixing that in together, then of course the only thing you're missing is phosphorus in the right ratio to create a fertilizer. And of course here in the West Coast, most of our soils are quite acidic. And so it takes liming, right? And so if the pH is high from your catalyst, then you've also got that as well. So there's a lot of different pluses there using it for a fertilizer. And that's kind of the obvious one that we almost not added because we could have gone into a whole discussion on that.
Sure.
So this is different in different places, but what about what have you encountered about laws, regulatory environment in terms of disposing of the effluent, using it as fertilizer?
That was the subject of my master's thesis. Kind of. In Europe, they're getting there after 30 or 40 years of biogas, like Holland, Germany, these kind of places. They now actually have standards where, so in legislation that like classifying something as a waste versus a saleable product, at least in Europe, that's a big issue. I'm not super familiar with what's going on here, but they now, at least in the UK and in Holland, and they're working on at the EU level, some legislation that allows you to, with given certain quality requirements, it allows you to consider it a product rather than a waste. And in regulatory language, that's good news. Very, very briefly, in Europe, what's important is the pathogen levels, the heavy metal levels, and the organic toxin levels. That's what you need to please for the regulatory side of things. I could find you the relevant regulations in Europe. But on a farm level, what's important is the stability of it. Because if it still has volatile fatty acids, it reeks. There's a bunch of stability, and salt is also not that, like if it's municipal stuff, sometimes you end up with salt. So there's all kinds of things, but here, I'm working on it, I don't really know. In Europe, it's pretty well established, and yeah, it's from a practical point of view, it works really well as a fertilizer. After anaerobic digestion, in fact, the nutrients are very available, right? They're in ion form, like orthophosphates and ammonia and this kind of stuff. And then very briefly, I have a bunch of spreadsheets from Germany that list like huge numbers of things that were tested for biogas potential. I put together brown grease by taking a bunch, I took the number for vegetable oil, I took the number for food waste, I took a few things and kind of averaged them out and came up with this, which this is per 10 kilograms, so it's in the range of 300 per kilogram. So it's still very, very high, like manure on this range, manure would be like 500 or something. Whoa. So yeah, this is all of this stuff is high energy. However, I don't have experience digesting brown grease. We will have a reactor up at Bings Creek tomorrow that is digesting brown grease. And we're getting a little bit of gas off it, but I don't have results enough to say.
And that's kind of the subject of our next pilot. So again, as you know, biodiesel producers, it takes a lot of heat, a lot of energy input, and so we're looking everywhere along the chain where we can be really innovative and more sustainable with the heat, because that all has a cost bottom line as well. And so if we can look at all the waste products all along the line and stop looking at them as waste products and use them to create energy, then it's going to become one of the next things that we're looking at is I said, that biogas pilot. Yeah, so I think we've, yeah,
one more
couple of
question.
things.
Sure.
Yeah.
Glycerin you're using, that's like the methanol in it?
I haven't used
Have you
any.
tested one way and the other?
No, I haven't actually used glycerin at all.
Well, you know, and if that's taken from studies, then I would suspect that that doesn't have the methanol in it. That's
Yeah.
that's been recovered. But, and that's kind of a difference when you're looking at the glycerin, what you're going to use it for. Maybe if you're not recovering the methanol, then it's good for biogas. And if you are recovering the methanol, then it's a little more suitable for using, or it's definitely suitable for using as a fertilizer once you start mixing it with other things like manure. Yeah.
Yeah.
Well, yeah, I mean, we could probably do some samples with the methanol and the methanol out, but the idea is that methanol itself is something you want to recover back to the process. So if you can, which also takes heat as well. So all along the line, if you're going to be recovering the methanol as well, recovering it from your glycerin, recovering it from your biodiesel, then you need heat. And so this is just another way. Absolutely, yeah. And that's the thing that looks so promising, is that the numbers are so good, and it'd be interesting to see what the difference would be with methanol. But I think, yeah, it's still going to be high because the methanol is a low, you know.
Yeah, I have a comment about that. You know, methane is not the dream fuel. Biodiesel is a lot nicer of a fuel. Methane, it has such a low density that like it's a hassle to store it, right? And if you have the option of methanol versus methane, take the methanol. It's so much more valuable.
Yeah.
Can I interrupt for a moment, please? My name's Mike. Everyone say hi, Mike.
Hi, Mike.
I am the driver for the dinner group tonight. I need to know how many people are going. Is there somebody here that has a head count going to Cowichan Bay? Because I need to pre-trip a vehicle first before I leave.
I think we're probably going to be looking at around 45 people.
Okay, so I'm taking the big bus.
Yeah.
Okay,
Yeah,
great.
bus, too.
All right, that's the one that's right out front in the front area there, okay? Thanks.
Thanks.
Bye-bye.
Okay, so
You got a question here?
yeah.
Just a general question. Have you or the literature looked at the PKN ratios coming out of the effluent from the bioreactors, from the digester, and see if there has to be any kind of...
Those are all questions for the future.
Well, I can adjust it a little bit. It'll be identical to the NPK ratio of what goes in. There's nutrients don't go anywhere inside these things. And that's a big advantage compared to composting. I mean, I'm not going to say composting is bad, but I have to push the biogas thing every once in a while. And composting, you get a lot of carbon turning into CO2 and a lot of nitrogen turning into N2. Whereas in biogas, every single molecule of nitrogen you put in at the beginning comes out at the end as ammonia. Pretty awesome fertilizer. So yeah, that's all I can say. It'll be identical to what goes in. The NPK ratio. So if it's
You can lose your phosphorus in anaerobic digestion.
say again,
You could end up burning your phosphorus from the methane. It gets in the methane.
are there do you know of volatile forms of phosphorus?
Phosphine.
Yeah.
Yeah.
Right.
So the phosphorus
Now-
goes out as phosphine?
You can lose it, yeah. In a bad compost heap, at night, you can see the compost glow blue from losing your phosphorus.
Okay.
So,
Well,
and you'll definitely lose your sulfur, obviously.
that's right. Yeah. Now, in biogas, did you lose phosphorus?
Well, it's an anaerobic digestion,
Right.
so it is possible.
That hasn't really been an issue. That
When you look at the phosphorus cycle, it's largely sedimentary. It's largely bound.
Yeah.
And
I-
it's very hard to-
yeah.
Yeah, but
I know that
it's a QC issue with a good anaerobic digestion.
Okay, see that's a little bit of outside the scope of anything I've ever seen before, but yeah, you're right that there are volatile forms of phosphorus, but I think they're pretty rare, and I don't think that it's significant, the amount that's lost. I'll have to look at it though.
It's done well.
Okay,
You know, you've got what was it, siloxane or something? Siloxane, which is something that could screw up a turbine if you ran your
But that
landfill
that
gas.
comes from soaps and health and beauty products. And in this kind of application, you probably won't have that income.
Okay.
Anyways, I think we'll have
Yeah.
to move along here. So your biogas pilot in Machosen.
Okay, well, here's a system that's running on Vancouver Island that's been running for the last 3 and a bit months, and it's been producing biogas every day. It's being fed chopped up weeds from an organic farm. Weeds have a lot of energy, grass clippings, stuff like that, and so this is going to heat the greenhouse in the winter.
So is it just being direct fired?
Yeah, you can go back a couple of slides and you can see the burner. One more. So this is the burner.
Okay.
It's kind of jimming together. It has a shut-off valve if there's no gas. It has a thermostat, and it's just, well, you can see here, it's just a burner. It's the burner that's taken out of the barbecue.
And does it have an automatic lighter, or it's?
Yep,
Yeah.
but yes, I mean, the pilot has to be going in order for the
Okay.
thermostat to run. And yeah, so there's me with shit all over me. That was fun. So it started with cow manure. So what comes out looks like cow manure. That's it.
And I think, yeah, I think we're kind of ending there. It's kind of funny because we're bringing in a whole different level of dirty here. You think oil collection is a dirty business. Now when you start combining it with biogas, it's a dirty business. So, and I think that's pretty much it. And so we've really answered questions all along the line, but we've still got probably about another 5 minutes here for questions if anyone would like to ask any. Yeah, yes.
So I'm wondering about, has anybody looked into, anybody here know about looking into fermentation of glycerin? Whether that's...
There's someone in Texas this year who just published a study on anaerobic fermentation, and apparently it was quite amazing what happened with glycerin. But I haven't. But I emailed the guy and I haven't heard back.
So what alcohols came out of that process?
I'm not sure. Yeah, be interesting to find out.
Yeah, a lot of questions, but a lot of energy stored
That
there.
would be a much nicer product than gas. If you could make alcohol,
Yeah.
do that.
Yeah, but then you'd have to do, for it to be useful, then you have to multi-stage distillation done. That's the problem.
Mhm, exactly. So we're looking at simple, kind of cost-effective solutions here too. Dan?
So what is it, I mean, what's accurate just burning it, just in its raw state without cleaning it up?
Well, there's something that scrubs the hydrogen sulfide on that system in Machosen there. But apart from that, yeah, and the water is designed such that the water condenses, so it's mainly methane and CO2 and maybe a little bit of traces of other stuff.
Is that, big, expensive, tricky work to clean it up, or?
H2S?
Yeah.
It can be if you take the conventional solution. Exactly. That's what I'm using. I'm actually using rust.
You can also run it through a scrubber filled with steel wool.
Yeah.
Steel wool rust.
Yeah, rust. That's what I'm using is rust. But there's a bunch of different ways of removing hydrogen sulfide. You can also add a tiny bit of oxygen into the reactor, and there's bacteria that will turn it into elemental sulfur. There's activated carbons on the market that you can just buy and plug in, like a cartridge that'll do it. And yeah, the most elegant or the most simplest, in my opinion, is just using rust or ferric chloride or any kind of, I think it's iron 2 that bonds with sulfur and makes iron sulfide.
It seems to me that you waste methane. It's one of the biggest pollution problems.
When you're looking at it from a greenhouse gas perspective, it's 21 times more potent than CO2 in the atmosphere. So burning it, converting it to CO2.
Correct.
And it's already from a biotic source.
I've been saying that for 15 years. And it seems that somebody who has a normal house and food waste and some humans, there probably is enough energy that's leaving the house or rotting in the yard to heat and light the house.
Yeah, and that's interesting. So going back to Kealan's little pilot that he had in Holland, his house in Holland. So you imagine that outside running your barbecue.
Yeah.
Your outside barbecue. Every house could have one.
It's not enough to heat your house. It's roughly enough to cook on if you use all your feces and your kitchen scraps.
Just enough to cook.
Yeah. So.
Yeah, I mean cook. Depends how much you cook. I mean, depends how much what the temperature is. But
yeah, exactly.
But it's not a huge amount. I mean, you still need something like solar thermal or whatever. I think.
You guys, I think we'll take maybe one more question. Yes.
Your solar thermal system, it was a Weissman Biodiesel that you had up there?
That's right.
Is that a hot water tank and heat exchanger all in one? Is that like,
Coil
is
and
that your
tank.
reservoir with the heat exchanger and heat exchange tubes in it?
What's the actual, well, they sell them as a set, I think. They make both products. But we bought just the solar panels because we got the actual heat exchangers surplus. But they were actually made by the same company anyways. They were the Weissman ones, so.
There's a Canadian panel, Enerworks, made in Guelph, I think it is, that probably has similar BTUs per square foot. Might be another option. I think they're like $1,500-$1,600 a panel.
Yeah, there's a number of different products.
Not the panels, but the actual, these orange and white tanks there?
Yeah.
Is that like for your hot water storage or coolant storage?
Well, yeah, it's just a common heat exchanger. So the actual glycol is circulated through coils, and actually I can go back. The coil in the tank, I have a diagram of that.
And that's your storage? That's your
Yeah, the oil is in the tank, and then there's a coil that runs through, basically, which.
A heat
brings in-
transfer fluid.
That's right, heat transfer fluid, yeah.
Okay.
The glycol is. Yeah, exactly, and that is another use of glycerin also. There we go.
There is the tank.
There's the diagram. Okay, good. Well, great. So I don't think we want to hold you any longer because now it's the other great draw for the Collective Biofuels Conference, and that is the social.